Welcome to this UK Agri-Tech Centre podcast, where we're exploring one of the innovation feasibility projects that we've supported. Starting back in April 2024, the Carbon HarvesTech project is an Innovate UK funded farming innovation programme looking at the feasibility of direct air capture of carbon dioxide in controlled environment agriculture. In conversation with project partners and industry experts, we'll explore more about this innovation. So let's dive right in. We have three guests on the call today, and I should probably quickly introduce myself as well. My name is Wallace Currie. I work for the UK Agri-Tech Centre, and I focus on dissemination and knowledge exchange for the Adopt Fund, which is an England-based farmer-led open innovation fund looking to match farmers, growers, horticulturalists and arboriculturalists with facilitators to lead on-farm trials. And I also do quite a bit of podcasting on the side. The guests we have, or the contributors to this podcast, are Ahmad Mosheni, Eirinn Rushbridge and Alexander van Tuyll. I'm just going to give you a quick introduction to them here. Ahmad's the founder of Flex Farming and involved through Brits Energy. Ahmad works at the intersection of energy systems, controlled environment agriculture and direct air capture innovation, with a strong focus on practical deployment, commercial delivery and the future integration within horticulture. For Eirinn, he's the senior engineer with NFU Energy. On GrowSave, Eirinn works closely with growers across controlled environment agriculture and horticulture, supporting energy efficiency, sustainability and knowledge exchange within the horticultural sector from an independent consultancy perspective. And then Alexander is a researcher at Wageningen University, specialising in greenhouse systems, non-fossil carbon dioxide enrichment and the future integration of direct air capture and circularity technology within CEA systems. So just to jump straight on in, Eirinn, I think you're probably best to answer this. What is the purpose of using carbon dioxide in controlled environment agriculture?
Sure. I guess the fundamental is that maintaining a controlled environment, which you need in controlled environment horticulture, is expensive, and therefore it's really important to optimize the crop production to extract as much value out of the process as possible. Higher concentrations of CO2 within the greenhouse or polytunnel of the system will increase the yield from your crop and potentially the quality as well. You can maintain ambient levels of CO2 with enough ventilation through the structure, but generally above ambient concentrations are better, and therefore ventilation ends up acting against your CO2 concentration. So that's essentially why supplementary CO2 is added into a greenhouse.
Have you anything to add to that, Alexander?
Yeah, I think Eirinn's description was very complete. I've got a couple of thoughts. The first one is that CO2 is a bit of an interesting input because it's not like water or fertilizers where the crop will die without it. It is optional, but of course it leads to higher yields, which means, as Eirinn said, you get more out of your system and more per square meter. The other thing about CO2 is if you don't use external CO2 in many situations, like a hot day like today where it's very sunny, you can get indoor concentrations below ambient, even as low as 200 ppm, and then it can be very harmful for your crop. So no matter how much we apply, it will definitely have a very important role in the future, as it does now.
Ahmad?
Well, as Alexander said, for glass houses, for vertical farming setup, it's crucial because the density is much higher, and also because when you are in a day mode, in order to maintain the climate within the grow room, kind of in a efficient and commercially sensible way, you want to be in a recirc, and as soon as you go into the recirc, the CO2 concentration in the air would drop and deplete. So you have to do those, otherwise you would be wasting the other resources if you don't have sufficient CO2. And what we do for strawberry cultivation, we actually raise the CO2 to around 900 ppm, which is much higher than the ambient CO2. So we do need to have a supplementary supply in place.
And to those that aren't experts in this world, of which I will raise my hand, I don't know if this is a video podcast or an audio podcast, but I've raised it here on the call. Alexander, you talked about there when it goes beneath that ambient level, it's not a necessary component as CO2, but what happens when you go beneath that level?
Yeah, if you go beneath that level, your crop will just be a lot less productive. I mean, it will be maybe order of magnitude 50% as productive as it would have been at ambient. And above ambient, of course, it can be even more productive. So not only is it bad for your crop to go under 400 ppm, but it also means that, as others have said, you're not getting as much out of your system. And to produce the same amount of yield, you're going to need more square meters, which means more of other inputs, and could mean your environmental impact goes up. So there's that too.
And sorry to bombard you with another question, Alexander, but could you outline the sort of current supply and accessibility of carbon dioxide for horticulture?
Yeah, so for the most part, it's fossil. And I'm speaking from my work that I'm doing in the Netherlands, but there are two sources. The first one is on-site through the CHP or the boiler. So the grower will burn natural gas, that releases CO2 as a byproduct, and that's then given to the crops. The other source is industrial. So the Netherlands is quite fortunate to have this network of pipes called OCAP in the western part of the country. And their industrial CO2 from companies like Shell, but also biogenic sources, although that's a minority, are piped to greenhouses as well. And for growers who don't have access to that system, it's compressed, bottled, and sent there. So it's mostly fossil. And I'm sure we'll get into this later, but fossil sources are under pressure at the moment.
Can you give us a wee bit of a sort of focus on the UK, Eirinn?
Yeah, of course. It's very similar. Unfortunately, we don't have the access to the CO2 pipelines that are there in the Netherlands. But in general, it's either going to be natural gas combustion, either CHP or boiler on site, or industrial compressed liquid CO2, which generally comes from fertilizer manufacturing. The reason, CHP is sort of ubiquitous in a lot of particularly edibles because it's so valuable. I suppose we can probably get into that a bit more later, but it's in terms of a CO2 producing asset, CHP has got an awful lot of value. Other sources do exist. There's some waste stream from biogas upgrading, for example, but the number of sites where that CO2 is captured is much lower, and typically, if you're buying liquid, it's going to be coming from fertilizer manufacturing.
And what are the main challenges surrounding this sort of system, Eirinn?
Yeah, I think the biggest thing is price volatility, both from either burning gas on site or from fertilizer manufacturing, particularly with the fertilizers. That again was tied to natural gas. It's methane reformation that they use to generate that hydrogen that they use for fertilizers, and the CO2 is sort of a byproduct. And so when gas becomes expensive, as it did a few years ago, and it's started to do again recently, some of those businesses chose to close their doors in the energy crisis a few years ago, and we saw costs, CO2 costs, if you're buying liquid, increasing by up to sort of 400% very quickly, and the supply drying up. So that sort of price volatility and supply volatility is really the biggest challenge. There is another one that I'd like to sort of highlight as valuable as CHP is as an asset for mitigating electricity costs in particular, and for making money in electricity exports. It has benefited from schemes such as the CHP quality assurance, which allows for a relief on certain taxes because it's recognised as sort of an efficient technology. However, particularly in more modern years, there's been a more scrutiny on the emissions side of some of these sort of efficient technologies, and CHP is quite emissions intensive technology. So if some of those sort of benefits that CHP has historically benefited from, if some of those are taken away, or if the gas supply has some additional sort of carbon taxation or something added onto it, then the financial case for generating CO2 on site becomes much worse. And that again is quite a challenge for future CO2 supply.
And how have you felt, I guess, following on from what Eirinn said there, Ahmad, is that quite accurate to what you've found? Have you found other challenges, or have some of those not impacted you as highly?
No, I think everything Eirinn said, that makes perfect sense, especially when referencing to the fuel crisis a few years back where the two factories closed down. I believe those two factories would have supplied 80% of the CO2 used in the food system as a whole. And as a result, I remember that at a certain point in time, forget about the price, which hit £3,000 a ton at some time. It was simply you couldn't get hold of CO2. And I think the reason there is that CO2 is not just been when you look at the food industry, CO2 plays a critical role in packaging, slaughterhouse, all sorts of different places like, carbonated drinks, which has much higher value and can afford paying more, whereas horticulture is a low value industry and we cannot pay as much as they can pay. And as a result, when the price goes up, they go and buy, and then we end up not having access to CO2. So yeah, I think that was one of the biggest challenges. But at the end, as long as we are dependent on fossil fuel, which is an imported product itself, it means that the whole industry is dependent on an import when it comes to CO2.
Yeah, and we're in a world of, there's always been geopolitical volatility, but it seems to be much more common. We're seeing notable changes without getting into politics for the sake of this discussion. But Ahmad, for this episode, what is Carbon HarvesTech project, and how does it address these challenges we're focusing on?
Yeah, as I mentioned, we came up with this idea of kind of CO2, local production of CO2 or local supply of CO2 when we came across all of these challenges around access and price of CO2 delivered to site. From vertical farming perspective, the industry needs to be very kind of self-sufficient when it comes to power. If they want to be dependent on the grid, you see what has happened to the vertical farming industry over the past couple of years is the price goes up, the business model breaks and out of the business. So it has to have that integration with local energy generation, specifically renewable, because if you want to not be dependent on fossil fuel, then you need to have a level of renewable into the energy mix that you're addressing. And we were saying that, okay, if we got access to energy sorted and that access is kind of secure through renewable, so it's not fossil fuel dependent, why not use that to capture CO2? From the ambient. And then what we are trying to do here, usually when you look at direct air capture and CO2 carbon capture as a whole, they usually focus on capturing the carbon concentrated into the liquid or something that they can sequester it permanently, which then adds a lot of complexity to the whole process. Whereas what we try to do is we try to increase the ambient CO2 from 400 to 900, let's say. So that's a simpler problem to address. So we looked at different technologies and different methods for CO2 capturing. We concluded that vacuum pressure would be a good one. There's also a temperature swing, which are another method. And then we put it to practice. And then obviously, because the percentage of CO2 in ambient is 0.04, so it's so little. So capturing that level of CO2 from this whole kind of a million particle, and we got 400 to extract from it, economically becomes very, very challenging. So that's one part of it. The other side is that when we looked at the way that CO2 is being utilized, especially in glass houses, we instantly realized that this is not going to work for glass house because the way that they do vents. So 80% of the CO2 that they put into the glass houses, because they want to, the way that, not all, but majority of glass houses, when they want to control humidity, they open the vent and the CO2 goes out. So it's 80% of it lost. So imagine that you're paying so much for the CO2, you cannot afford to lose it like that. And then the whole target segment of horticulture that we were looking at all of a sudden shrunk into more efficient systems. So those glass houses that have a sealed environment and they are using dehumidification rather than venting, and vertical farming, because vertical farming is kind of a sealed environment, so it's more efficient when it comes to CO2 utilization. But still, there is a challenge there. So when we look at the crop-specific economy, for example, for a strawberry, if the price of CO2 goes above £500 a ton, then it doesn't worth doing the dosing, because the gain that you receive from the sales of the product doesn't balance it out. And the reason that we are doing it is because we don't have any other option. So for the reason that I mentioned earlier, but whereas when you look at glass houses, they simply decide not to dose it and just take the hit of lower yields. So yeah.
Do you know, when I speak to folk like yourself, Ahmad, I just feel so insignificant at my ability to find a solution to a problem. It's what you've.
But that's the same feeling that I have.
Well, it sounds like you're being very successful. And I guess the question to that is, you've talked about some of the potentials there, the ideas, the concepts, and some things in practice. But what are the technical difficulties that you've came across that you have been able to resolve?
I guess the key at the core, we wanted to prove within this project the concept of, can we capture the carbon molecules and then release it back into the environment in a controlled manner? Yes, we can do that. Can we oversize the system that then we don't need to do the compression and the storage, because compression and storage is another element which consume a lot of electricity, a lot of energy to do. So if we could size the system in a way that it runs in tandem with your growing cycles, you would reduce that requirement and consequently reduce the cost. So yeah, that approach does work. But at the end, we are still dealing with that 400 particles per million, which then make it a kind of a scientifically and from physics point of view a difficult process to do it cost effectively. That said, the methods such as temperature swing would require a lot of heat. So if you co-locate with places where they have surplus heat, low waste heat, or geothermal, or whatever that give you that free energy, you can use that to the benefit of this process to reduce the costs. But that would require an integration into a wider system to make it work. If we want to look at it as a single component and try to make it economically viable, it's going to be a very challenging. And I think the key challenge is if we go one further deeper into the system, is the adsorbents that we are using. So these adsorbents, there are different types of adsorbents, but basically what they do, there are cavities inside these little adsorbents where the CO2 molecules get stuck in there, and then they get released by either introduction of heat or vacuum pressure. So there is a specific adsorbent which called metal framework, MOFs they also call it, metal organic frameworks, where they design the cavities, which it helps avoid all of the other content in the air, because one of the key challenges is that you blow the air over the adsorbent. It's not just CO2 and all sorts, but there are also other things such, and the biggest one is the moisture. So the adsorbent gets filled up with the moisture before it captures the CO2, so the efficiency of the adsorbent get reduced. So these new materials that is being manufactured, they can be designed in a way that focuses more on the CO2 molecules rather than others. So it increases the efficiency and potentially help the economy of the whole system. But I would still think that it has to integrate into a wider kind of system to benefit from those unlocked energy sources such as heat.
Have you anything to add to that, Alexander?
Yeah, well, I think what Ahmad said was, it makes me very happy because these are the similar findings that we're getting here in the Netherlands. So about concentration, about price, about efficiency, but also integration with what other systems are there in the context. From our side, we've done some trials with direct air capture machines from a Dutch company. And one of the things we were looking at is how do you independently test one of these systems, not just on paper, but also once it's actually in the greenhouse setting, and what sorts of challenges come up, and what things do you need to test. So things that we were looking at were quality of the CO2, so contaminants, or whether they come from the air or are concentrated by the DAC system, things like that. We looked at crop safety. Does the crop respond to that? It didn't in this case, luckily. We also looked at condensate, because as Ahmad mentioned, a lot of water goes through a direct air capture system. We looked at energy use and other things around, practical greenhouse integration.
And when you've sort of covered this through this episode, Ahmad, and well, everyone has really, but this whole project is now at a stage that you're able to give out results. Part of this podcast is part of that dissemination project. So what were the final results, or what are the final results of this project?
Well, the final, I guess, if I want to express the outcome in a simple term, is that it can be a sustainable source of CO2 with high level of accessibility and security of supply. But when it comes to the cost of it, the cost was more than what we've been expecting. So based on our modeling, we were expecting to consume around 4 kilowatts power per kilogram of CO2, but in reality, it was more around 8 kilowatts, so twice as much. The other issue was that because of these moisture and high humidity challenge that we have in the UK, you end up regenerating the absorbent material more often, so the maintenance cost would also go up. So it all goes back to the economy of the end produce. And then if the application that uses CO2 cannot afford the cost of it, then it's a no-go.
But there's a lot to be said for, first off, the being open about that. But I think the thing that's important to say there is, if you've got that accessibility and security, that's very much more important than that uncertain world we've been speaking about for the whole time. Plus, price will come down as you develop. I assume, I'm not an expert in this world, but when you continue to look at something, you're currently 8 kilowatts, one day you'll get it to 7, 6, and then one day knock down to that 4, and maybe one day lower. So I would say if you've got a successful product that's accessible and secure, I mean, that security part and what is purely based on a market of volatility, I think is a really strong thing to start with. I would say maybe you've got higher aspirations and you're your own worst critic type thing, but certainly looking in, that would be my opinion.
It definitely, what you said, that makes a perfect sense. And when you look at other technologies, it follows that same trend. So it will carry on and improve. But I think as an immediate or more medium-term solution, the integration will be the key. So because when we look at that, let's say 8 kilowatts, if you get access to waste heat or geothermal or another source of heat, you can reduce that by almost 70%, which then instantly bring it under a more economically viable solution for adoption. But I agree with you that going forward, especially the focus that has been put onto MOFs is accelerating, and those materials potentially can solve these issues.
Yes, it seems pretty positive to me. It must be said. And Eirinn, you're a independent consultant with regard to this, Eirinn. When we look at horticulture, how does that industry view direct air capture?
Yeah, I mean, in short, very interested. I've had quite a few growers talk to me about direct air capture. We've put out some publications on the GrowSave website about direct air capture specifically from a couple of different manufacturers that we've met with and spoken with at various events. I mean, the market uncertainty, the sort of volatility means that direct air capture, it represents an alternative route which, albeit does need some energy to work, it provides a more sustainable and more reliable route to getting that CO2 that you need. I think that it's important to say that there has also been a bit of a trend into more sort of semi-closed growing systems with a bit less ventilation, more screenage, more screen usage throughout the day, and occasionally more screens in general. And that, as Ahmad said earlier about vertical farming being the sort of prime use case for direct air capture currently, with growing systems moving towards more of sort of semi-closed environments, from an energy efficiency perspective is why they're doing it. But a sort of downstream effect will be that when these systems become more sort of viable on a larger commercial scale, it might be that the sector is ready for that transition. I think that growers need to be quite prudent. It needs to make financial sense. And at the moment, the units that are commercially available, they can be restrictive, not only in the capital cost, but also in the footprint. How many of these units you need per sort of hectare of greenhouse, for example, it gets restrictive if each one is sort of shipping container sized. So there's a few sort of kinks to work out. I think, at least from my perspective and some of the people that I've spoken to, I think that there's no reason why there couldn't be a sort of transition. We've seen it a bit with heat pumps recently, where rather than relying on a large heat pump to deliver all of the heat that you need to your greenhouse, you'd have a sort of combination of a small CHP with a medium-sized heat pump, and that delivers electricity and heat and CO2 in different quantities. Pairing that with something like a direct air capture, so that you've got that heat already being generated, maybe via CHP, so that you can sell some of the electricity for additional value, then, as I was saying, the economics, the financials of running that direct air capture unit makes more sense. And then, potentially in the future, when the developments get better with the technology, or when the energy markets get to a place where combustion just doesn't make sense anymore, or, as is often the case now, having electricity connection in the UK is prohibitively expensive, then having a sort of even an off-grid system that combines some form of CHP with heat pump with direct air capture, I think is a likely future.
So, I mean, yeah, very much accepted, just needing to get to a spot where it can be brought in easier, for sure. And again, I think that comes down to that time thing. Again, I'm going to assume that will be being worked on. I don't know if you've got anything to add to that, Alexander.
Yeah, just to say that growers are really interested in alternative forms of or sources of CO2, because, I mean, right now in the Netherlands, most growers use CO2, and it means they have 20% higher yields, roughly, depending on the crop and so on, compared to no CO2. So it's a really important topic. And as current sources are going to become less and less available, they're interested in alternatives like direct air capture. And I think the most important thing they want to know is, how much is this CO2 going to cost, and how does it affect my greenhouse system? And, cost, at the moment is an issue, and energy as well, potentially. But it doesn't have to be prohibitive, because, as Ahmad was saying, 80% leaves the window. Of course, that depends on the grower, but in many cases, even 90%. So even if your CO2 is more expensive, if you can figure out how to use it more efficiently, then that could be an opportunity as well. But in the Netherlands right now, growers pay 10 cents, maybe less, to up to maybe 20 cents per kilogram, just to give you an idea. I think if that price can come down, that will be a big opportunity. The other thing to remember is, it costs energy to produce CO2 using a direct air capture machine. But if your yields are lower, then to get that same yield, you're going to need a bigger greenhouse in theory. And that means more growing medium, more heating, and all these other things. And so I've recently been doing some calculations on this where, in a semi-closed situation, especially where you can be more efficient, direct air capture actually may mean that your energy intensity of your produce goes down as long as your yield compensates for the energy you put in. Greenhouses, CEA, especially vertical farms, are intensive systems. The question is, does adding to that intensity increase yield more than the energy you put in or less? And I think with direct air capture, there is potential in the future.
So, it sounds from the last probably 10 or 15 minutes we've been talking there that this resource, what we're talking about here with HarvesTech is good. It works. It's doing what it's meant to do. But the next challenge is price, is getting it accessible from an economic perspective. So with that sort of hat on, Ahmad, what business models exist in this space?
I think that we look at different business models, and I think obviously when it comes to new technology adoption, first of its kind challenge and risk is always there for the early adapters, and one business model that could alleviate some of the uncertainties around that is CO2 as a service. So it's basically through a financial institution, they finance the device or the capital. A company would operate it and charge the maintenance cost, and then the grower would be charged only for the CO2 that they get supplied with. So they don't need to worry about the maintenance and the capital installation costs. The other model is to be is a capital sales, which has its own challenges. One area that the colleagues at the UK Agri-Tech Centre looked at was policies, how we can generate, how this sort of technology can benefit from policies and around carbon capture utilization. And while there are some kind of discussions going on, there is no set procedures or finalized facilities that growers can tap into to reduce their costs. And I think a lot of it goes back to validation of how validation and meterings of CO2 being captured and utilized, et cetera, which is itself is a very difficult subject to have to seal it off. With sensors and things. So I guess it very much limits into these two business models that we looked at: capital sales or off balance sheet and CO2 as a service.
Yeah, I think that makes sense. I was quite interested to ask you that because I was trying to rack my brains as to what else could operate, but I think what you're saying has to be the case. And that is coming from someone that's just listening to this over the last few weeks, to be honest. But I think that makes a lot of sense. And when we're looking at DAC, Alexander, how can we integrate direct air capture more effectively?
Yeah, it's a good question. And the conversation has already emphasized a lot of the aspects that are really important for DAC integration. So the most important thing is look at the context where you'll be applying it, because there are lots of opportunities that growers or the installers can make use of there. And the first aspect of that, of course, is energy, the elephant in the room, perhaps, in controlled environment agriculture in the world, even, you could say. As Ahmad said, if you have a geothermal source, then that can greatly increase the sustainability of DAC. But also, thinking about how perhaps existing heating systems can be integrated into the DAC system. And the other thing is perhaps timing, because in terms of sustainability, when the electricity grid is flooded with solar energy, then DAC has less of an impact from the impacts of the grid than, say, in the middle of winter. And luckily that somewhat matches the demand from the crop, at least in a greenhouse. So that's energy. Scale is also a thing that might be an opportunity for DAC. The question is, should it be installed? Should each grower have their own DAC system, or would it be better to approach this on a sort of hub cluster level? Are there efficiency gains to be made there? Perhaps if they have varying demand patterns, flattening that out, things like that, but also, of course, economies of scale. And the last thing that's really important, and I'm really glad to have heard it here as well, it's good that sort of great countries think alike, you might say, because, concentration is really important. In the greenhouse, we only need maybe 800, 1,000 ppm if you're really, really pushing it. So that's 0.1% by volume. And so does the CO2 from our DAC machine need to be 100%? And what we've seen in simulations, if you just look at the volume of air that you need to move to get that CO2 in, you only need about 1%, so 10,000 ppm. And above that, it doesn't make that much of a difference. But of course, it depends on what your system looks like again, because if you want to use an existing system of pipes that growers use to distribute CO2 from a CHP, then you might want to have 5%, 8% to fit that existing infrastructure. And then, of course, we haven't talked about storage yet, where 100% is a lot more efficient if you're doing that. So I think it depends on whether you're bringing it into the greenhouse directly, how you're doing that, and then if you're thinking about storage or maybe even supplying CO2 in times when you don't need it yourself. But I think going through those three things, so energy, scale, and concentration, I think that can help integrate DAC more effectively.
I think there's one other thing I'd add on to that has been mentioned again previously on this call, is the efficiency of usage on the end of it. At the moment, a lot of CO2 that is put into greenhouses is wasted, and humidity control is the biggest reason why opening vents is very easy way to control humidity, but it does cost a lot in terms of energy, but also in terms of CO2 loss. So improving the efficiency from more sort of semi-closed, closed environments, managing that humidity through either dehumidifiers or forced air ventilation is I think a really important part of making the most out of the CO2 once it's been captured.
When you're looking at the consideration of, I don't want to use the word error, but let's, for the sake of what I'm trying to explain, operator error, like you've just said there, Eirinn, is there an education training piece between the likes of Ahmad and that user at the end of the line?
Yeah, certainly. I think one of the challenges is that if the system has been designed, if the greenhouse has been built to be operated a certain way, then retrofitting dehumidifiers or sort of gable end forced ventilators can be very difficult and sometimes just not possible. So part of it comes down to when a new greenhouse is being built, to build it for the use case. So yeah, I think that's certainly the knowledge exchange, absolutely very important, and that sort of training piece to make sure that the grower will be growing in the way that they have been, that they've learned over the many years of that they've been in business. So yeah, when there's a new way of doing things or a slight change to that, it's important to get that sort of knowledge exchange through the whole supply chain, really.
Did I see you had something to add to that, Alexander? Was that?
Yeah, just to say that, because I think it was Eirinn who mentioned efficiency. It's a really interesting point for CO2. I can't remember whether it was Ahmad or Eirinn who mentioned that, strawberry prices are too low, then growers it's not worth it for growers to give CO2. And I think growers are constantly making that economic optimization, right? So yeah, if CO2 is more expensive, then it won't be as worthwhile to dose that CO2. Another thing, though, is that efficiency is not constant throughout the year, of course, and in some simulations that we did, but I'm pretty sure it would apply to growers generally. It's an interesting question to ask anyway, is that the majority of the additional yield that you get from CO2 comes from a small minority of critical moments through the year. The 80-20 Pareto principle, that kind of thinking that, if you just eliminate your most wasteful moments in the year, then you can dramatically increase the efficiency that you get from that.
Ahmad?
Yeah, I think it was what Eirinn mentioned around dehumidification, especially in the context of glass houses. We did a quick modeling to compare whether it was having a dehumidifier in the room to avoid the wastage of CO2 in comparison by using the existing strategy around climate control and those place the CO2 with DAC, and the first step has to be dehumidification. It also much based on this case studies that we looked at, the installation process was also much easier. Also, convincing the growers is easier because dehumidification technology has been already there, it's proven working, and you can kind of guarantee certain percentage of gain by simple calculation. It doesn't have anything unknown within it. So when looking at glasshouse setup and those not maintaining a sealed environment, the first step to improve even on CO2 is to control humidity so you waste less.
I mean, you've sort of just touched on one there, Ahmad. We've sort of looked at through this episode, we've looked at what we're doing with this project, the challenges we've faced, the results that we've found. Albeit results are here, and you have a duty now, a desire to express what you found. I don't feel like this is, once those results are out, it's finished. So you sort of touched on the first step there. What are the next steps in general for the Carbon HarvesTech project?
Okay. We are that for Carbon HarvesTech, we think that our segment or target market are those who can utilize CO2 very effectively and very efficiently. So that's the target market. So we are going to tune the system based on their requirements. But at the same time, we are now working with companies who are developing these new adsorbent materials, which are very, very much more effective and efficient compared to the existing one. And on the third side, we are looking to see how we could integrate with these other other systems, such as heat pump and CHP and so on and so forth, in order to minimize the cost of running a direct air capture system. So these are the key elements on the roadmap that we need to prioritize and address as we go forward. One good thing with us is that we keep, while Brits Energy is very much focused on the energy efficiency, flex farming. When I put my flex farming hat, we are very much into commercial viability of those solutions being developed, because if it's not going to address the key needs of the grower, it's really hard to imagine that it's going to be adapted simply because of its sustainability. And the whole area, I mean, that the key matters that we mentioned here is security of supply. That security of supply makes sense as long as the business can carry on. If you end up with a solution that helps your security of supply, but you're going to be bankrupt anyway, so it's just that security of supply meaning is already gone. So I think it all goes back to how economically viable the solution is. Then the matters around sustainability and security of supplies, all of those would come in.
It'd be quite interesting to hear from, I don't know if Alexander or Eirinn, you have anything to add from that, maybe not from being directly involved, but what you'd like to see down the line with this project occurring after now.
I think the most important thing from, at least when I speak to growers, is they like to see a site that's commercially doing it before they invest in anything. As many sort of pilots or sort of proof of concept type sites where it exists and it's working, and a grower can come and have a walk around and talk to people and sort of ask questions about how it runs and how they've had to change the way that they grow, all of those kind of things. That sort of face-to-face visible technology is much more easily taken on board compared to seeing a report or a spec sheet from a piece of equipment.
Alexander?
Yeah, I'd say the same. If growers can actually see it being applied in practice, then that will really become a catalyst for the further adoption of DAC. And yeah, for the time being, in terms of our follow-ups, we're also looking at fine-tuning DAC systems, in all the different aspects that we've looked at. And yeah, I think the interesting thing is we're seeing a lot of different approaches, and many of those could be eliminated, depending on what works, what doesn't. But at the same time, there will be a big variety in how these systems are deployed, depending on the context of the greenhouse or the vertical farm. So yeah, fine tuning and then being able to show growers at scale that this works. I think those are the two next important steps.
Well, I mean, I think having come into this project and hearing about it mere weeks ago when we set up this podcast here, it's quite interesting to see what's happened throughout the course of this project from your perspective in particular, Ahmad, but then also external integration and who's helped along the way. And I think it just seems like a journey of building on that security and accessibility that exists, trying to play into a world where it's more affordable, but also, as sort of Eirinn and Alexander have just touched on right at the end there, growers, farmers, whoever, work on tight margins, maybe sometimes seen as fickle, but with reason. This is a tight margined industry that's so impacted by the volatility we've covered a few times. It's just sort of working towards that stage where what is clearly probably more than even proof of concept, an actually working project, a successful project being implemented across the board. So to the three of you, Ahmad, Eirinn and Alexander, thank you very much for your time.
Thank you.
Thank you. Pleasure.
Yeah, thanks a lot.